Hey everybody, welcome to the Tetris Pieces Code Along. If you've already been, then thank you for coming. And if you're watching this from the start, let me start by explaining what we're going to do today. For this code along, we're going to be making clouds on a screen, and the clouds are going to consist of 4 circles, and we're going to move the clouds around, and we're going to talk about how to generate a bunch of different clouds. The first step that we should highlight is what the code looks like when you start. So give your program a run and get familiar with what's going on. So now back to the code. After you've tried running your program, we have an app class. The app is pretty unfilled currently. All we have is our bubbly cloud scene, and we have a light blue background. In our constants class, we have scene width and scene height, the size of our bubbles, and coordinates, which we'll talk about in a little bit. And for our pane organizer right now, we just have our root. So the general structure, like I said, is we're going to have a cloud that's full of 4 bubbles, and the bubbles are going to be circles. So I'm going to start by making a couple new classes. First, I'm going to make a game class because we know we're going to want to delegate to a top-level logic class like we have been in past projects. The next thing I'm going to make is our cloud class. And the last thing I'm going to make is our bubble class. For the purpose of this project, we're going to start at the bottom. Let's start all the way from the bottom with the bubble class. Neat little trick. You can click and you can press generate, and we generate ourselves a constructor. And what is our bubble? We want our bubble to act as a wrapper class for a circle. Similar to Doodle Jump with our platforms and our doodle, our bubble is really just a circle with some additional functionality. So we're going to import a JavaFX circle, and this circle is going to be each of our bubbles. And then let's see which constructor we can use. I think we should be able to use center X, center Y, radius, and fill. So 2 of those we already have. We have the radius that we saw in the constants class, and we also have the fill because we're just going to use the color white. The question is, where do we want our circle to appear on the screen? Well, our cloud is going to have 4 different circles or 4 different bubbles, and we're not really sure where each one's going to show up. So what we're going to do is every time we create a bubble, we're going to request 2 parameters, an X and a Y, and we're going to pass that X and that Y into our circle. Always JavaFX, color white. And now what have we done? Every time we create a bubble, we're going to create a circle. And now one question you can ask yourself, have we logically and graphically added this circle to the pane? One question is, do we even have a pane? No. So should we create a pane in the bubble class? That would feel a little bit backwards. The point of our pane organizer is to create all our panes. So instead, we're just going to associate our bubble with a pane. And eventually, we'll see how this pane comes into play. But the point being is, we're not going to create a pane in our bubble class. We're just going to tell our bubble about a pane. And now we can say pane.getChildren.add this dot circle, right? And we can add this dot circle because it's a JavaFX node. And now, if we run our code, we're not going to see anything because we haven't actually added our pane, but we have now logically and graphically created our circle for the future. Now, what else are we going to want to do with our bubble? One thing, which we know we're going to have to do eventually, is move. Our Tetris pieces are going to move, so our bubbles and our clouds are also going to have to move. So let's just say we want to make a move right and a move left method. And I'm not going to fill these in right now, but I just want to highlight that eventually we're going to need to fill them in because we want our bubbles to be able to move. And now the last thing is we see bubble is gray. And what does that mean? Class bubble is never being used. This makes sense because we set up our bubble, but we never did anything with it. So now we're going to explore our cloud class, which is actually going to take advantage of our bubbles. And one thing to note is that every single time we have a cloud, it has the same amount of bubbles, 4. That might sound familiar to Tetris because every piece has 4 squares. So we're going to hold, again, we're going to make our constructor. But we're also going to create an instance variable of an array. And our array is going to store bubbles. Bubble array or cloud, whatever naming convention you'd like. And this dot bubble array and what does this do? Have we actually created any bubbles? No. But what we have done is we've set up the structure which is going to contain our bubbles and store them logically. Ideally, we now need to create our actual bubbles. A better name would be generate cloud. And let's write this method. This is going to be private because it's a helper method. That's just going to help us generate our clouds, or a cloud in this case. And what do we want to do? We want to loop through our bubble array and populate it with a bunch of bubbles. So one good way to do this is a for loop, int I equals 0. I is less than, we can use 4. We could also use bubble array dot length, I plus plus. Add a nice little spacing. And we want to say this dot bubble array I is going to equal a new bubble. And what this is saying is we're going to loop through 4 times, 0, 1, 2, 3 for the 4 indices of our array. And we're going to create a new bubble at each step. Now, when we create a bubble, we've demanded that we receive an X, a Y, and a pane. Let's first start with the pane. How are we going to get a pane? Well, again, the same reason we didn't create a pane in our bubble class, we're not going to create a pane in our cloud class because we're waiting for our pane organizer to do that. So by the same logic, we're going to do this. Or we're going to pass a pane into our cloud class. And then we can just pass it right in there. And again, one thing is we could have created an instance variable for this pane to do the same work. But because we only use it in one method, it makes more sense to just parameter pass down. And now we have our pane. Now, the next thing is, where is our bubble going to be located, right? Because when we make a bubble, we ask for X and Y. And that's where our circle gets created, at these X and Y coordinates. So let's take a look at the constants class. Right here, our unused constant, cloud1, is a 2D array of integers. And what we can see is a 2D array structure. The best way I like to think about this is we have, in this case, 4 distinct arrays of size 2. And how we're going to think about this is any given array is coordinates. So in this case, our first bubble, or our first two-dimensional, not two-dimensional, size 2 array is our coordinate for our first bubble. So likewise, these are the coordinates for our second bubble, third bubble, fourth bubble. And our first index, by convention, we're just going to name the X, and our second, we're going to name our Y. So for example, this would be the X coordinate of our third bubble, X coordinate of our fourth, Y coordinate of our third, Y coordinate of our fourth. And now the question is, how are we going to actually extract these values in a meaningful way? Let's say, for example, if we were to write cloud 1, 0. What does this represent? All we're saying, this would also have constants in front of it, but we'll get to that when we get to our other class. What we're saying here is that give me the 0th element of my 2D array. And as we can see, our first element is not this, but it's the entirety of this array, because our outermost array, which is denoted by these brackets, holds arrays because it's a 2D array. So our first element is actually this entire thing. So what about what would this represent? Well, the first thing we're doing here is what we've just said above. These are the coordinates for the first bubble. And the second thing is, once we get those coordinates, we're accessing the 0th element, which that's going to take 205. So cloud 1, 0, 0 is 205, or more accurately, X chord for first bubble. The next thing we can do is think about what this would return. Well, the same as the start, we're going to access our first bubble coordinates. And instead of this time, the X coordinate, we're going to access the Y coordinate. So this would be 300 or Y chord for first bubble. So let's use this information in our actual cloud class. We want to access a different coordinate each time. So let's say we have our int X coordinate and our int Y coordinate. Like we said here, our X coordinate is always going to be a 0 because it's always the 0th index of all of these coordinates. So we can access our constants. It's going to be 0. But if we write 0 here, that is just going to be the X coordinate for the first bubble every time. Instead, we want to slowly increment through the 2D array so we get the X coordinate for every bubble. So what that's going to look like is I. This way, when I is 0, we're getting the X coordinate for the first bubble. Then when I is 1 for the second, and et cetera, et cetera. And likewise, we're going to have the same thing here. We're going to access 1, like we talked about before. And now we have our X and our Y. And what this is doing is we are now setting up the bubbles really nicely for our cloud in a super cohesive way, where we have delegation to our constants class, where we create these coordinates. And then our cloud class just takes really nice advantage of the coordinates and then also delegates to the bubble class, which actually creates the circles. This is setting up a really nice delegation pattern, which we'll talk about maybe a little bit later, but it will be helpful to have a similar delegation pattern in your Tetris to make your code really organized. And again, ultimately, what's some other functionality that our cloud is going to need to know how to do? Move. So let's create public void move, right? And again, I'm not going to fill those out. I'm just going to acknowledge that we're going to eventually need to because our cloud is going to have to move. Now, let's go to the game class. Again, let's generate a constructor. And what do we want our game class to do? We want to handle top level logic. So what is that going to mean? Well, our cloud is going to get generated in the game class. So let's say new cloud. And cloud requires a pane. So what should we do with our pane? Again, are we going to create our pane in our game class? No, it's going to get created in our pane organizer. So let's just do this for now because, right? And now you can see that whatever pane game gets, cloud is going to get. Whatever pane cloud gets, bubble's going to get. And whatever pane bubble gets, the circle gets added to. So that's that really nice delegation pattern of the pane throughout our entire program. And now our next step is we want key pressing. So let's do on key pressed. I think it's this one. And then there should be some familiarity, always Java FX. With this, we've been doing this for some projects now. And let's say we're going to have a helper method on key. I like to call it handle key press. And we're going to pass in our key code or our key event E. Now let's make this, again, always private because it's just a helper method and it won't be used anywhere else. And now, like we've been doing with these, we want to switch based on e.getCode. And let's say case left. Cloud dot move left. And we can see one issue we've ran into is we don't actually have our cloud. So private cloud. This is going to give us access to our cloud down here so that we can call this dot cloud dot move left. Then always remember to add your break. This dot cloud dot move right. Break. And then again, what do we always need? A default statement. And because we don't want anything else, it's just our keys. We can just press break. And then again, we want to consume. And this should be set up. What are we saying? We're going to create a cloud and we're going to set on key pressed. Case left, case right, move left, move right. Now let's go back to our cloud class. Move right and move left. What do we want to happen? When we move right, we want each of our bubbles to move to the right. Because functionally, all we're doing when we're moving a Tetris piece or a cloud bubble is moving the individual square or the circle. So we want to loop through our array. And this would be a really good time to use a for each loop because we can say bubble per bubble in this dot bubble array. Right? And we see how this reads really nicely because we've had a really nice delegation pattern. So for anybody reading your code, maybe a grader, maybe in the future when you're doing partner projects and in other courses and your partner downloads your code, this is really easy code to understand right now. We can see exactly what's going on. Our game class is really simple and easy to read. And also our bubble. This delegation pattern is really nice. And then the final step is to actually move right. We have our circle, so we can say this dot circle dot set center x, this dot circle dot get center x, plus I'll make an offset constant. Bubble. Let's do 4. See how that looks. And then we can copy this. Some of you might be wondering why I'm making 2 move methods. You don't have to. You can consolidate into one. I like move right and move left because it reads really nice. But you could definitely make 1 move method and just switch depending on which direction you want to go. There's a lot of options. Maybe in Tetris, when you're moving left, right, or down, you just want to make 1 move method that handles all those. That's completely fine. But yeah, and then this should be set up really nice. We have really good design pattern through these classes. The last step is you can see our game is not being made anywhere. So again, we want to pass that all the way up to our pane organizer. Let's make a pane for our game. And let's say, set center. Right. And again, now we see this game pane is the game pane going to our pane, to our game, which is in the center, which again gets passed down to our cloud, which gets passed down to our bubble, which gets passed to our circle. So that's the really nice delegation pattern we want between our pane organizer and our classes and our top level logic. And that all started because in bubble, we said we don't want to create the pane here. We're just going to ask for a pane. And now you can run your code and see what comes up. I don't think it'll show up on the screen. But nice. What I see is, hopefully you see this too. You see a cloud, and when you go to move it, it doesn't work. What do we think is wrong? One thing I want to emphasize here is mistakes happen all the time in CS, especially as we get into these harder projects. Very rarely are you going to code something and it's going to work the first time. But one skill we really need to have is debugging. So one thing I want to try is walking through some print lines to see what's actually going wrong with our method. So I saw that we created a new cloud, which worked, but left and right didn't actually move the cloud. So I'm going to try to write a print line. You can always write a print line a lot easier by typing sout and then tab. I'm going to try writing a print line here, and I'm going to call it got into the key press method. So what does this mean? I'm going to run my code, and if I see in my terminal that this is printed, that means we're actually getting into our key press method, and it's an issue somewhere here. If I don't see this line in the terminal, then I know it's an issue with this line of code, or something to do with why handle key press is never actually getting called. So if you run it again, you're not going to see my screen. Maybe you see the terminal, I'm not sure. But what you should see in your terminal is you don't see the line of code, which, like I said, means there's issues going on elsewhere. So the next thing I'm going to try is I'm going to write another print line up here. One thing you can do, you can say before and after. So now if I see before and I see after, I know our pane should be setting the key press right. If I only see one of them, then we'll go from there and see. And when I run it, what do we see? Before and after. So I know that set on key press is getting called. So with a little bit of thinking, what I can come up with is that we're setting the key press to this method, but our keys are not actually focused on the pane. So this is when we can remember that we need to set focus traversable to true for this pane. And again, my debugging process really helped me because the first thing I ruled out was that it's anything to do with any of this, because I learned that it has nothing to do with the handle key press method. It wasn't even getting called. And that's because we didn't set our focus. Maybe it's better to put this in front. I don't know if it matters. And now let's run it again. And what you should see now is that our cloud actually moves. This is awesome. And this is just a nice step in the debugging process and how we can use print lines to analyze what's going wrong with our code. Now, the last step that we're going to do in this code along is answer the question, well, in Tetris, you're not just going to have one type of cloud. You're going to have a cloud that is horizontal. you're going to have a cloud that is a box. You're going to have a cloud in all different types of shapes. So let's make constants or a coordinate for a second cloud. Let's call it cloud 2. And let me see what I want to use. I'm just going to play a little bit of guess and check. Let's do 220, 300, 200, 320, 220. In your actual project, you can just, it will be a little bit more structured because you'll have the board. Yeah, let me just add a lot to all these, so it's just clearly separated from the other one. And now, let's try generating a cloud at random. So what I'm going to do is every time I create a cloud, I want to change which cloud is going to be generated. So specifically, I want to ask for some extra information every time I make a cloud. I'm going to ask for coordinates in my cloud. And rather than ask for the first cloud every single time, instead, I'm going to ask for coordinates. And what that's going to look like is we're going to pass this down here. And we're going to pass this in here. And again, we're not going to use an instance variable because it's only in one method. And the idea here, or I'll go back here and explain. This is kind of what our old code looked like, and this is what our new code's going to look like. And the difference is, let's say we have 3 or 4 or 7 different types of clouds or pieces. We can't just say, get me cloud 1's coordinates every single time. We need to be able to say, I could want cloud 1, I could want piece 1, I could want piece 2, I could want piece 4. So instead, we need to abstract our cloud class a little bit so that the actual coordinates we get for the cloud can be different every time. What that now looks like is our generate cloud method takes in coordinates, and we use those coordinates when we loop through our 2D array and we create our X and our Y. And now here in our game, we can see we have an issue here. So let's say we just want to make our first cloud. This will be the same code that we had the last time. So if we go to the cloud, chords is now constants.cloud1, which is just what we had before. So if we run this code, which you can see on your screen, we get the same exact thing as last time, same functionality, no difference. But now the point is we can also create with our same exact code a different type of cloud. So let's just try saying, I'm not even going to give it an instance variable. Let's just say new cloud. Constants dot cloud 2. Pane. And again, I'm not going to go into detail about how we would move both of the clouds because that's not really a problem in Tetris. As you might find, you only have one active piece, if that's any hints. But what we can see is that now we're going to create 2 clouds instead of 1. And the only difference is the second one has a different set of coordinates than the first one. And likewise, when we go to our cloud generation, these coordinates that get passed into here and therefore into here create different coordinates for our bubbles, which graphically will appear differently. And when we run our code, we can see that now we have 2 different types of clouds on the screen. We have our first one, and we have our second new one that we've generated. And again, we have a really nice delegation pattern because in our constants class, we create 2 different cloud coordinates. And then when we create a cloud, we can very easily pass in which set of coordinates we want to create that given cloud with. So one thing that could be a slippery slope is creating a bunch of different classes for a bunch of different clouds because they're kind of different. But again, all of our clouds are going to have the same functionality. Move right, move left, in Tetris, move down, rotate, all these things. So creating 7 different classes for all of our different pieces would be a really tough design choice because we would be repeating all of that code and it's not worth it to do all of that. So instead, we just want to do all the same things except for a slight difference, which is that when we create our cloud or our piece, we want a different set of coordinates each time. So again, hopefully if you're running on your screen, you're seeing 2 different clouds. And again, only the first cloud will move because of the way we've set it up. But like I explained, that won't be an issue in Tetris because you only need to move 1 piece at a time. I hope this was helpful. If you have any questions, I went relatively quickly because this is a longer amount of code. Please always feel free to post on Ed or go to conceptual hours and ask about the code along. Good luck on Tetris, and we hope this helps.